I am Praneta. I belong to S2 mechanical branch. Yeah. So today I'll be talking about an interesting topic in statistical math called as Benford's law. This law has a lot of potential and uh, can be used in detecting frauds and stuff. Is quite an underrated law, mostly known among mathematicians, but can be used really well if if known correctly. Yeah. So if you ask a question to somebody that if you want to pick up a number from 1 to 1 lakh maybe, what's the probability that the number you have picked start from 1? Any normal person or who doesn't think much or who doesn't know this law tells the probability would be 1 by 9. So 1 out of 9 chances you would pick up the number starting from 1, because there are 9 possible events, and all are equally likely. So the person would say 1 by 9. What's the probability that the number you have picked starts from 2? Again, it's the same, 1 by 9, because all events are equally likely. But in nature, actually, this doesn't happen. It's Yeah. So that is why this law comes up. This law, what it tells is, any data, any data you pick, any set of data which has quite a nice and well, quite a nice and a big sample space. So so this law is applicable there. What does this law actually tell? This law tells that about 30% of the time, the number the number that comes up starts from 1. Then about 17% of the time, the number starts from 2, and it goes on decreasing like this curve. So yeah. So why does this happen? It's a pure consequence of nature. uh, this has been observed in any set of data. If you take a bunch of numbers from a financial newspaper, if you pick up a page and find a circle around all the numbers in that page, you would find about 30% of the time the numbers you have circled start from 1, and then it goes on decreasing up to about 11% of the time it starts from 9. Yeah. So why does this law have a lot of potential? This is because it can be applied anywhere, literally anywhere, except some cases where the sample space is too small. This can be applied in cases like population density of countries, or the total population of countries, or the length of rivers, or this is the law also which tells why the initial pages of the book are dirtier than the final pages of the book. Because yeah this law because the initial pages start from 1, then the final stages final final pages also doesn't start from 1. So that is why the initial pages actually are more dirtier than the final pages. Yeah. So this law is not applicable in cases where the sample space is too small, as I said, because if you take example of an average of if you take the data of all heights of all adults in on earth, it would mainly lie between 1 meters and 2 meter 1 meter and 2 meters. So it's not a good enough sample space. So it's not applicable there. And but if you generate numbers from a website or a computer generated numbers, the probability would still be 1 by 9, because it's computer generated, and this law cannot is not artificial law. This law completely arises from nature. you know you could take any set of data. I mean, the set of data could be literally anything. The numbers from a newspaper, as I said, the numbers from newspaper come from different sources and different channels or different stock exchanges. They also follow this law. The numbers you pick up, they 30% of the time start from 1. Yeah, so this is the beauty of that law. And why is this yeah, can has a lot of potential to detect fraud too? Because you can use this if you have a class, in a class you have around 200 students. If you plot the marks of all students, they have to follow this law of this. They have to get a curve of this, and 30% of the time the marks would have been starting from 1. Yeah, so if you make the units correctly and adjust according to this law, so if it doesn't satisfy this law, it means that that particular student who has got that marks has done some fraud or fraudulent things, or copying the exam or something like. So yeah, this has a lot of potential in detecting frauds too. Thank you.